Tech Transform. My name is Vinay, and today I'm going to start a new playlist for Apache Hudi. So basically, in this a particular video, I'm going to tell you about what is Apache Hudi, what is the need of Hudi in the data lake, typical data lake, and where and what are the use cases behind this Apache Hudi project, and what are the various Apache storage type Hudi provides. So we are going to discuss a lot of things are in detail. So let's first start with what is Apache Hudi. If you go to the internet, you can find out a lot of informations, a lot of definitions are there, and you can get often confused. So I'm going to give you a very basic idea about this. So we have a typical data lake storages like Amazon S3, HDFS, or any cloud storage, and on top of that we have Hudi data lake. So basically it's a like uh, uh, Hudi dataset on top of your typical data lake, and you have typically many more data sources like databases, Kafka streaming, apps, and microservices. So basically, what Hudi does, Hudi gives you transactional benefits over your data lake. So what happens in your data lake? You're not able to update anything. You're not able to even if you have to do a small update, you have to uh, re-downloaded everything, rewrite and then re-upload it. So it is going to take a lot of time. But on top of that, Hudi Data Lake provides your transactions features on top of a typical data lake. Like you can do row level update, you can control concurrency, you can delete a record. So a lot of things you can do. And Hudi basically when you have like traditional databases and data warehouses where you can you want to do like row level update, but there you can do, but those systems don't scale so efficiently. But nowadays people are using data lakes because we have varieties of data coming from, and data warehouse and data houses, they have limitations. They cannot uh, go to a different data sources and aggregate results and give it back to you. So that's why we have to go with data lake. But the problem we were facing, we wanted to have databases like features like transactional features in data lake also. So that's what Hudi solves this purpose. And once you have like Hudi dataset on top of your lake storage, then you can query those Hudi datasets like by using Spark, Amazon Athena, Hive, Presto, Trino, and all those things. So let's move again. So what are the common use cases? Let's say you want to delete some privacy data. So according to GDPR, you can delete. Government can restrict the uses of the personal data. So where let's say you want to delete data and you have petabytes of data, let's say 500 petabytes of data is available, and you want to delete a single record, how you're going to identify that? And in nature, typical data lake like Amazon S3, SDFS are like mutable. So what you have to do, you have to download the data, modify it, then re-upload it, and it's going to take a lot of time. So data freshness is also an issue here. Let's say till the time you're updating a record, a new record is already arrived, and a lot of downstream systems are, let's say dashboards are already dependent upon your data. So these are the things problem was having with the typical data lake. And also let's say you want to let's say you have you given time and you ingested all the data, but what about the data freshness? What about the latest change which is keep coming, like latest inserts, latest update? What you are going to do that? So these are the problems also. These are very major problems, and how you're going to apply that, right? So uh, how you can ingest high volume of data, and how you can give an data ingestion as a streaming basis, how you can like make sure that there is no duplicate records, and how you are thinking like some of the scenarios where you have to like give write performance query or read performance query. So what in that cases, this typical data lake have a lot of problems. And also once you stream your data, once you're streaming your data to a data lake, it is very faster, but is going to create a lot of small files, because it is going to create a file as the data comes in. That is fine. You're going to achieve the speed, but what about if you want to query those data sets? Due to this smaller file issue, your query get impacted, and your performance query will not be performant. So you need to think about that, managing the file sizes appropriately also. So actually this Apache Hudi, this project created under Uber. What was the use cases they were trying to do, what was the problem they were facing. So this was the motivating factor behind this Apache Hudi actually. So let's try to understand briefly what was the problem they had. So let's say from the Uber, you do a trip like daily, you can so they have their typical storage for their Uber trips. So they were storing the trips related to today's, yesterday's, or last month, or you can say past years, up to 10 years, up to 11 years. And suddenly, let's say you want to update yesterday's data. You want to give a feedback to your driver yesterday's for your yesterday's trip. So you are giving lot of incremental update, right? A lot of incremental update are happening, but you have to apply those changes on a real time manner, because from this lot of downstream systems are already dependent upon this data. And let's say if we are giving an incremental update by the typical, what happens in the typical data lake scenario, you are just your long running bad job is running, and let's say you have 500 petabytes of data is already there, but you have to do a very small change in a single file, but you have to recreate the entire thing and re-upload it. So it's going to take huge time, and there will be issue, because for the Uber type of use cases, they want to be rely on the real time data, not on the very late arriving data, right? So that's what the motivating factor behind the usage, because Hudi provides you incremental update. So whatever the, it will keep you, it will give you like the benefits, you can apply only the incremental update, only the delta data, not the complete data you have to rewrite. So it will just go and change in that particular file where your record sits. So that's the benefit of using Hudi. Okay. So what was the problem with the typical data lake site, like slow data lake? Like the batch ingestion is too slow. Like they don't have like intelligence inbuilt. They used to typical ETA. What it will do? It will recompute everything. It doesn't apply any intelligence, because it is mutable. It just it needs to recreate everything. A small file problem. If your fresh data is arriving on an even manner, and like you end up creating a lot of small files, right? So that's what the, once you're going to query the data, due to this small file you're querying is going to perform not be performant. Let's say you already have a bad data in your data lake. Now you want to roll back to your data. There is no way you can roll back to a different into a time, for a different time, right? And there is no way you can avoid duplicates records in your dataset. So these all the problems were with the typical data lake, and Hudi solves all these problems. So from the Hudi, what you are going to get, like you are going to move away from big batches and run, right? You're not going to run big batches, whether you're going to run just incremental update, incremental data, right? Mini batches in a streaming fashion, that's the same thing. And Hudi provides you different views based upon the scenario. You can like it can provide you read optimized view. It can provide you incremental view, where you can query your data as per the need. Okay. So with the Hudi, what was the actual things possible actually? It can give you near real time data ingestion. Yeah, because it's just pass the delta data to the data lake, not the complete data. You can do a stream processing also on batch data, because like as the data comes in and it's very fast, and you can process it. Row level, it will give you row level deletions, like to simplify your data privacy, because it gives it enables your data lake to have a transactional feature. So you can update your single record, you can insert update new records with the indexing. So Hudi maintain a bloom index on top of for your each of the records. So what it will do, it will have an index, and from that index it will be able to identify, okay, on which file, on which partition this particular record is sitting, and I need to update only that record. Also, Hudi provides a snapshot query, means at a given time, let's say T0, it have a different snapshots of the data right now in the data lake. Then at T1, we have different data as the new data comes in. Let's say at any point of time you want to roll back to a certain time you have committed the data. So you can just simply Hudi will provide you that thing, and you can just roll back the data at a given point. Also, it provides a snapshot isolation between writer and query. So at the same time, it will allow you to query the snapshots also, and also it will allow you to write the data to the Hudi dataset. And Hudi manage the file sizes very efficiently. Like it's have their conscious decision on managing file size, because we have a lot of problem with the small size. So it it has an algorithm internally where it is going to give you good size, so that your querying is not going to not in trouble when you are going to querying this data sets. Okay, let's quickly move and let's try to understand how Hudi works and what is the overview of that. So what happens, you have your data lake, let's say Amazon S3. On top of that, you have created Hudi dataset. How you're going to ingest data to this Hudi dataset? So either you can use Delta Streamer, so that's provided by Hudi. You can use like streams of data, change logs, database change logs, Apache Kafka streams. They can directly stream to the datasets. They can directly use the Delta Streamer and ingest data to a Hudi dataset. And another way, using Spark data source, you can create your Spark data frame just with the data and just insert those incremental data to a Hudi dataset. So up to here you have Hudi dataset created in your Hudi format. So basically it is also a file format, it is also file format, but this is specifically to a Hudi a specific format. That's what Hudi and it's stored in Parquet format. So it gives you three type of views. You can, based upon your need, you can have an incremental view. You can like select a star from this incremental view. You will get only the data, change the data, only the CDC data you're going to capture it, and what the data is going to change. So delta data you're going to just query it from the last timestamp what the new data just arrived. Read optimized is like at a given point of t0, what is the latest record in my Hudi dataset, it will gives you. It doesn't allow compaction, so we are going to understand what is this compaction and all in going forward. And real time is at a given point t1, what is the latest fresh data I have. So it will combine the read optimized plus the incremental data, and it will give you the real time data. Okay, all moving forward. What is the Hudi architecture inside? Like inside the Hudi dataset, what are the things are there, components are there. So there is an index. So this, by this index you are going to identify a record uniquely in which partition and which file it is sitting, and you are going to apply changes to that file only. And you have data files where the actual data file sits in, and you have metadata and timeline data where it's it Hudi used to keep keep snapshots of every time you're committing the data to Hudi dataset. Let's say at time t0 what changes you have done, at time t1 what new versions of your data you have. So all those timelines and metadata is being maintained by Hudi. And finally you can just read this data Hudi dataset either using Presto, Spark SQL or Hive. You can query your like you used to query S3, right? So you can directly query this Hudi dataset, which will be like very performant. And Hudi provides two types of storage, storing the data. Actually, Hudi dataset stores in two ways. One is like copy on write, and second is merge on read. So copy on write is by default you are going to set you're going to create Hudi dataset, and you're going to save that by default. Even if you're not providing the storage form for storage types, it is going to create a copy on write table. And other side we have merge on read. So what is the difference? So there is a trade-off. Let's say you do reads frequently, so in that case you have to go and create copy on write table, but you do writes efficiently, means you're doing fewer reads but you're doing higher writes. In that case merge on read possible. So they have their internal architecture. Due to that this is read heavy and this is write heavy. We are going to understand going forward. Okay, so basically two types of storage types, COW and MOR. we call it. So now let's understand what happens internal in case of you're saving your data and querying from that copy on write storage types. So let's say just consider this hypothetical scenario where I am going to insert 5 records. So A, B, C, D, and E. So it will go to Hudi internally decide, okay, I need to divide, I need to bring these two A and B record to file 0, and B, C, D to file 1, and E to file 2. Okay, so this is at time t0. You have inserted the data or committed the data. This the at time t0 you have this data just came into the Hudi data set. At this point of time, at time equal to 0, you want to perform a query like select star from this table. So what will happen? It Hudi gives you for this storage type copy on write COW. It gives you two types of views. Read optimized, incremental. So see, let's see what is this at this point. What we are going to get in read optimized. So we are going to get in A, B, C, D, E, and incremental also A, B, C, D. Incremental is like because this is the time just all the data is coming, so both are actually simpler. So here you're not able to make any difference. Let's move. Now let's say we are updating some record. So like initially it was D, now we are making D to D prime, A to A prime. So these updates came. So what happened? Hudi intelligently have maintaining an index, and what it will do, it will create a copy of this file, file 0 to file O prime, file 0 to file 0 prime with the latest record. So A become A prime, and B, when B was not changes, so B was as is, right? And the next change is like D become D prime, right? So CD, it's copied to a new file, file 1 prime, C comma D prime. So two records came, and it was like same because there were no changes in the file in this file too. So at commit time equal to 1, at this time if you want to fire this read optimized query and incremental query, see what you're going to get. So read optimized is you're always going to get latest rate data. So what it will do, it will not read from this, it will read from this version. So A prime, B, C, D prime, and E, it will return this in this read optimized. But in incremental, what will happen? It will just have the delta data, what you have updated after time 0. So after time 0, what we have done, we just updated like D to D prime, A to A prime. So it will give you A prime, D prime. So it will give you the delta data at any given from the last commit. Let's say again in the third transaction, what I am doing, I am just updating E to E prime, A to A prime, and inserting new record. Okay. So what it will do is, so we change A prime to A double prime. So Hudi will, what it will do, it will create a new version of this file 0, and it becomes file 0 prime prime. Okay, so A double prime and B, and there is no changes in this C and D prime, so it will be remain as is. And as the new record inserted, so Hudi, I told you that it maintains the file size also, optimal file size. So it is not going to insert record here, it will go to record which have fewer records. It is going to choose that file which is having fewer records. So now it becomes E prime F, right? At this time, let's say I want to query this read optimized view. So what will happen? This will become A double prime, B, C, D prime, E prime, F. So this is the read optimized query, means the fresh data you have, the latest data I have in your Hudi data set, and A double prime, E, F. So it will give you like the delta data from your commit time t equal to 1. Okay. Move to next storage type, that is merge on read. We call it as a MOR also. It provides you like three kind of views where you can do read optimized, incremental, and real-time queries you can perform on this type of storage type. So basically it's an advanced version of storing Hudi dataset in compared to copy on write. Here like what happened internally, let's try to understand with this hypothetical scenario. Let's say at given point of time I want to insert 5 records, so A, B, C, and D. So this is my current at time 0. I have committed this A, B, C, and D. So this is my current snapshot of the data, where you can see like file 0 contains A record B, file 1 contains C, D, and file 2 contains E. Now let's understand. We got the update and where we want to update D to D prime, A to A prime. So at given point of time t is time equal to 1. So what will happen in previous cases, in case of CAW tables, copy and write, what was happening, it will create a new version of file 0. But see here, it didn't create a new version of file 0. So it just it knows that okay, D is in which file, in file 1. So what it will do, it will create a log file separately for this file 1. It will create a corresponding log 1, and it will keep moving the data to this log only. But in case of copy and write, it was creating a new version of this file 1 itself, right? So here in case of merge on read, it is not going to happen. It keeps up and appending this log. So this file 0 files are like in columnar formats, and these are like row format. So this is saved in parquet and this is saved in avro. And you know, in row based file formats are very write efficient, so that's why we call it merge on read, to be write efficient, not read efficient, right? So it just keep changing the data. It's not wasting time in copying and creating a new version. It's just appending a new change of the data to its log, corresponding log file. Okay, so like let's say it's time equal to 1. Now I want to fire a query. So at time of t equal to 0, everything will be same because we just have the data just inserted, right? So now time equal to 1, if we fire a query and we want to, like, from the real time view, select star from real time view from the Hudi dataset. So what you're going to give, you're going to get the latest record, like read optimized in COW. But here read optimized is different in case of MOR. So we'll see how it is different. So you can see now we are getting the latest record like A prime, B, C, D prime, because we just changes A to A prime and means A to A prime, right? And D, right? So we got it, like and incremental, what we did, we just changed only these two fields, like A prime and D prime. So we got that. Read optimized view, it will take from your base file. So this is like the file and this is like the logs. Logs always have the delta data, and but it is have the last base file, you can say. So at time equal to 0, so what was the base file? So what will happen in the early stage, compaction happen and this compacted to a different base file, right? At that time, if you fire a query, you will get the latest data. But right now your read optimized query will return A, B, C, D, E, not the latest data. Okay. But in case, let's say we are again doing an update, like A to E to E prime, okay, A to A prime to A double prime, okay, and a new record we are inserting F. So what will happen? So A, it is not going to create a file 0 prime, it is going to create a new log file corresponding to this file 0. So now A become A prime and B become A prime become A double prime, and E become E prime, and new record F came. So now at this given point of time equal to 2, we want to file a real time view, we will get the latest record. So A double prime, B, C, D prime, E prime, F. So this is the latest record, and incremental is the same from the last commit to this commit, what the latest data you got, what the changed data you just wrote in. So you're going to return only those delta data. So that is A double prime, E prime, F, right? These are the changes we have just given. Now at this given of at time 4, this compaction happens. So compaction basically means like merging these two files. That's why we call merge on read. So merging this file 0 and its log file means now in this file 0 prime, what will happen? It has the, after compaction, it merged all this delta changes and make it as a base file. So now if you query, now this file 0 prime, file 1 prime and file 2 prime, after the compaction, they have all the latest data. Okay. So what will happen? I'm just minimizing. Yeah. So what will happen? So it becomes, if you at this time of point, if you want to fire a real time query, it will return you the latest data, right? But incremental, there is nothing incremental because the compaction just happened and there is no log file. So that's why we do not have any incremental data, because incremental data used to go to log file, and in this case after compaction we don't have any log file, so that's why it will return nothing. And read optimized will again return the same thing, because read optimized is always reading from the base file. So in these cases, in these three cases, the base file were this only, but now after compaction this become the base file, file 0 prime, file 1 prime, file 2 prime. So it will take the values from here itself. So now this, both the real time view after compaction and read optimized view is same. So hope you understand this concepts, this merge on read and copy on write. In the upcoming video, I'm going to come with like uh, the hands-on what happened behind the scene. This is just the theory purpose I try to understand, but I will show you from the practical perspective and from the hands-on how we are seeing these things from the data side also. So that's all for this video. Thanks for watching. Have a good day.